did not cover this last year, so it'll be a little bit more detailed. Half of this is a pre-calculus section. But you're practicing using exponentials and logarithms and stuff, so it's worthwhile for us, because I know that we aren't the greatest with those. Right? But there is some calculus, if you remember differential equations and solving differentials by splitting x and y, separate variables, solve. Okay. This is one of those where you can use that method, or you can just memorize the differential and the solution. Okay, so exponential growth and decay deals with a function. We focus on that form. For some odd reason, the base E is the best base to use when you're analyzing exponential growth in nature. Okay.
Is that where E came from?
E? I don't know how they calculated it, to be honest with you. I'd have to look it up.
Wait, what is that? P-O?
P0, P sub 0.
E to P?
Okay, so what you're looking at here is P sub 0 is the initial size. Like if you have a bacteria that starts with 1,000 cells, that's your initial population, right? Or if you're carbon dating, there's so much carbon-14
Himmert,
in an object
Sarah
when it
Kane,
dies.
Rachel
Right, that's
Buss,
the initial amount, so.
Tyrell Kitson, Connor
Kate is our-
Ramsey, Jocelyn Long, Rhea Ludwig, Evan Scow, Ladee Sotelo. Please come to the office.
Well, let's call this a
They
day.
call me while I'm at the old school. I'm not even mad. I was like,
Okay, and this would be population size, basically, is what we're going to apply it to a lot, or amount. At some time t, right? So, just a general exponential. We did see that in pre-calc, but it's been a couple years, year and a half about.
Apparently E is just some, like a pattern that naturally pops up if you're trying to do like growth and things.
Yeah, it does. I can't.
is it like the Fibonacci series?
Yeah, it's like that. So
Couldn't it have
this
been
guy
two or
was
something? God.
this guy was doing like interest and stuff for a bank and found this number repeating over and over in every equation he did, so he just figured it out, and that's an E.
Yeah. Something like that.
Yeah.
Okay. So let's do a little pre-calc here. There you go. In the laboratory, the number of E. coli bacteria grows exponentially with growth constant K equals 0.41. Assume that 1,000 bacteria are present at time 0. Okay. A, find the formula for the number of bacteria, P of T of time T. Again, helps you memorize, right? So what is, so we have some annotations we could do. We have 1,000 and we have our growth constant, right? grows exponentially. What's our initial 1,000? E and then K is 0.41. You just made your.
The negative third.
Okay. Those are the units.
Why? So it's not to the negative third?
No.
But then why, how do you have hours to the negative first?
I have yet to figure that out,
Okay.
to be honest with you.
Are you sure it's not 0.41 to the negative first?
Yes.
That would just.
I am very sure. Okay, how large is the population after 5 hours? Where do you put 5?
And T.
Yeah, so P at 5, right? This is a calculator. Problem, so you bust that in.
$7,767.
Will we make a memory card for the exponential?
Yeah, that's everything.
We will. Okay. Can you have 0.9 bacteria?
No.
So is it approximate?
There's so much collusion going on, I really don't like it.
No, we're the ones, the rest of us are having a ball.
Yep, pretty much. All right, so how do you figure out part C? When will the population reach 10,000?
Set it equal to 10,000.
You did?
Set the equation equal to 10,000. Yes.
And we get to practice logarithms.
Wait. Can you just graph it and then find?
If you have a calculator available, you could graph 10,000, you could graph 1,000 e to the 0.41t, and you could do an intersection, right? If you don't have one available, you got to do some math. You agree with that?
Yep. Yes.
Divide by 1,000,
Yes.
okay? Do you agree with it? Okay, how do I,
Natural law.
yeah, I was trying to get the words out, I just wasn't coming out. That's what you do, right? Please, bye-bye. Good? And then,
Divide by 0.41.
yeah, so you get natural log of 10, 0.41 equals t. Now that's a fine mathematical answer, isn't it?
Yeah.
Except it doesn't tell us anything about hours and minutes. And we'll work with bacteria, you're gonna want hours and minutes, right? So,
So then you gotta actually figure
you
that out.
actually do have to figure it out.
Ouch.
And I'm pretty sure you get 5.62. Which is 5 hours, 37 minutes.
Yeah.
You know how to do that, right?
I have no idea what you just did.
I mean, natural log 10 divided by 0.41,
I got that part, but I didn't, what are the 37 minutes?
0.62 hours.
Well,
So you have 5 hours and 0.62 hours.
Okay.
So 0.62 times 60.
yeah.
Stop it.
Okay. Good there?
Yes.
All right, so pre-calculus problem, right? Okay, here's the calculus of it. This differential the way that these grow is you're constantly multiplying by another item, right? So if you have 4, it'd be times 4, then you do times, and it keeps growing up, right? So that satisfies the differential where all you do is you take your function and multiply it by your constant. And you take your function again and you multiply it by your constant. That's how it's changing. Okay.
So
So this differential has that solution.
So is this like an ever-changing summation? Or summation?
No. So basically what you have at time one, so let's leave this one again. At time one, right, your e to the 0.41. At time two, it's e to the 0.82. You've doubled that.
Okay.
At time three, it's e to the 1.23, right? You see how you're just multiplying by 0.41 every time? Or adding 0.41 every time?
Yeah.
Okay. That's what this is saying. Every time you multiply it by the same item. Up, 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 up. Okay. So the instantaneous rate of change is defined by the original times the constant. Okay. So let's look at example 2. Okay, find all solutions of y prime equals 3y with a solution that satisfies y0 equals 9.
Bobby Dupress, Ismail Pantalone, Tyrell Kitson, Cadence Honer, Zoe Metter,
Okay, what's your if y prime equals
Megan Olinger,
okay, y,
Megan
you have
Schaffner,
your k value, right?
Uh-huh.
What's your
Michael
initial
Eagle,
value?
please come to the office.
9.
Yeah, p of 0 is 9. Can you write your exponential now?
Yes.
Was the zero on the test last year?
No, this is, we didn't do this last year.
So it's gonna be equals 9
9 is your initial, e.
e to 3t.
There you go. You could take that differential, separate the variables, do all your differential math, differential equations, and come up with that same answer. Yeah, but what I'm telling you is that you don't need to. Do you remember separating variables?
Yes.
Yeah.
I mean, we could go over it, but we're kind of time limited right now.
Just our old thing over.
Example 3 is another pre-calc problem, basically. Well, I'm not going to go through it, but it's more pre-calc, except for part A. If you're going to express that as a differential equation, if pharmacologists have shown that penicillin leaves the person's bloodstream at a rate proportional to the amount present. So the rate is, right, so we would write something like, the rate is, of penicillin is proportional to the amount present. And this is going to be some constant, proportional. Why is it negative?
Because it's leaving.
Yeah, you're leaving. Good. So that's about as complicated as that one gets. Okay. Good. There is a question where you might be asked what was the doubling time. Okay. The really nice thing about these is the doubling time is a formula. Yeah. Right. So you could figure that out by doing some math on a pre-calc, right? Or you can just use the formula. If you remember it, you can use the formula. So what is K in this case?
0.08.
Yep. So in our question, the doubling time is natural log 2 over 0.0815, which is like 10 seconds or something stupid, right? 8.5 seconds.
14.
So that's a computer virus that,
Stupid, not 1.2.
when sent out, doubled the number of computers that were infected within 8.5 seconds. So after 2 minutes, they approximated that 71,000 computers were infected. And within 3 minutes, I think it was 9.4 million. Whoa, talk about exponential. But they, somehow it got stopped and it peaked at like 75,000,
Is
so.
that an actual virus?
Yeah, that actually happened.
Jeez.
Yeah, once a virus or a worm or anything of that nature gets out, there are so many vulnerable computers in the world that it's unreal. Just boom.
How many computers were fried by the time that they were able to stop?
Well, it says here that the virus didn't last anywhere than 2 minutes, or the worm, whatever it was,
Worm virus.
sapphire worm.
That's a pretty name.
So you can also do carbon dating half-life. Okay, if you're interested, I don't know if any of you are doing, environmental science, this might help, right? You can do your half-life, and it is the exact same formula as doubling time. Okay. The only difference is the value of K. It's going to be different, so it's going to work with numbers are going to work. So, I don't know what the specifics behind that, but half-life is exponential decay, so you're going to get a negative in the K. All right.
Yeah. But K will be because of the equation.
All right.
Because of the problem.
Here's the one free response from the DC exam that had exponential growth and decay on it. I would not expect it to show up again. This was 31 years ago.
I get to say it's overdue.
They might throw in a logistic, their favorite right now is the logistic equation. I'll show you that when we do differentials. But you have a bacteria population. The other popular one is deer or elk populations. They kind of switch back and forth. Write an expression for y. What factor will the population? This is really a pre-calculus problem. Okay, so
Bless you.
that's why they haven't put it on the calc exam. But if you're doing like biological modeling and you know the rate at which things are changing, you can write a differential and analyze the original function. That's what they tend to do on the AP exam now. So I'll show you some of those later. Any questions? So it's really an opportunity for you to practice natural logs and exponentials in context. Okay. There's a little bit of differentials in there. There you go. Okay. Tomorrow we will make cards make some memory cards for this, and I'll give you a pointer on how to answer. There's a question on the test for it, and then we'll do a review of calculator derivatives and integrals, and then let you study.
So we're starting a test Thursday? Or tomorrow?